Welcome to this video about IBM's new Spectrum Fusion product, a data services platform for Red Hat OpenShift everywhere. The focus of this video will be a technical discussion of the features of the hyper-converged infrastructure, typically referred to as HCI, offering of Spectrum Fusion. Spectrum Fusion provides multiple deployment options. It is available as an integrated hardware and software platform that can be easily installed in a data center. It is available in a software-only format that can be deployed within an existing VMware environment, and it will soon be available in a software format that can be deployed on public clouds. The focus of the remainder of this video will be the Spectrum Fusion HCI integrated hardware and software platform. At the foundation of IBM Spectrum Fusion HCI is the highly available infrastructure, including compute, storage, and networking, represented here by the white bar at the bottom of the screen. OpenShift on bare metal is installed directly onto all of the server nodes of the system. This is the red bar. Running within OpenShift are a set of HCI management services deployed as OpenShift operators that manage the compute, storage, and networking. The HCI UI operator provides a single pane of glass to manage IBM Spectrum Fusion HCI and is integrated with single sign-on provided by OpenShift. The storage operator deploys a best practices installation of Spectrum Scale Erasure Code Edition. The compute operator manages the physical servers, including their firmware upgrades, power state, and scaling the number of nodes in the cluster. The networking operator manages the switches, including the switch firmware, upgrades, and configurations. Together, the HCI operators monitor the health of the system for problem resolution, provide performance monitoring capabilities, present capacity utilization so that as a user you know when you need to add more drives for storage capacity or more physical servers to gain more computation capacity. Events are natively integrated with OpenShift and can call home to IBM in the event of a physical infrastructure or software problem with an automatic log collection and upload. IBM Spectrum Protect Plus is integrated with the backup operator to back up both the IBM Spectrum Fusion control plane as well as deployed client applications running on OpenShift. The upgrade operator orchestrates the upgrade of firmware on the hardware, OpenShift, the HCI management stack, IBM Spectrum Scale Erasure Code Edition, and Spectrum Scale Protect Plus. All of this integrated hardware and software provides the platform for running mission-critical applications in the form of IBM Cloud Paks, client applications, or open source packages. So what makes the Spectrum Fusion HCI product offering a powerful choice? Spectrum Fusion HCI is simple to deploy, scale, and operate. It is fully assembled in the factory and delivered ready to connect and power on, so it can be work ready in about 6 hours. Spectrum Fusion HCI easily scales from a base system to a fully loaded rack with flexible storage and configuration options. Because it uses OpenShift on bare metal, the resulting licensing costs are about 1/5 the cost of OpenShift on virtualized infrastructure. Its data services features provide infrastructure and operations teams the tools needed for simplifying data management. Spectrum Fusion HCI is expertly designed to meet the demands of running mission-critical workloads in production. It has a failure-resistant, redundant hardware architecture. Any hardware component can fail, and Spectrum Fusion HCI will be able to keep the applications running. Included are enterprise-grade Spectrum Fusion data services needed for mission-critical workloads, which include the ability to back up mission-critical workloads off-rack to Amazon S3 and restore to any point in time. Also included is expert care that gives clients a single point of contact for supporting the complete hardware and software stack. Spectrum Fusion HCI delivers high performance using a dedicated storage network for predictable performance. Redundant 100 gigabit Ethernet switches keep storage traffic segregated from data center traffic for secure and predictable performance. Storage-rich servers populated with NVMe drives are pooled and virtualized with Spectrum-scale ECE high-performance file system software. Multiple storage access modes are available to meet performance requirements for different classes of applications. Many AI and machine learning applications require GPU acceleration for training and inference, and Fusion HCI can provide this in servers populated with NVIDIA A100 GPUs. Model training is also supported by Spectrum Fusion HCI's high-performance file system that is powered by world-class Spectrum-scale technology, providing high throughput needed for model training. Installing OpenShift onto bare metal has many advantages, and Spectrum Fusion supports this configuration. Spectrum Fusion HCI installs the OpenShift CoreOS operating system directly onto the bare metal of the servers within the HCI system, eliminating the overhead that comes with using a hypervisor, and eliminating the extra operational complexity of a hypervisor, and freeing resources that can be used for workloads. OpenShift licensing can be as much as 5 times less expensive when installing directly onto bare metal. And having the immutable CoreOS operating system as the only OS on the servers reduces the attack surfaces and improves security. OpenShift sandboxed containers support provides users with built-in support for running kata containers as an additional optional runtime. This is particularly useful for customers who are wanting to perform the tasks such as running privileged or untrusted workloads, ensuring kernel isolation for each workload, sharing the same workload across tenants, ensuring proper isolation and sandboxing for testing software, and ensuring default resource containment through VM boundaries. OpenShift sandbox containers also provide users the ability to choose from the type of workload they want to run to cover a wide variety of use cases. You can use the OpenShift sandbox containers operator to perform these tasks such as installation and removal, updates, and status monitoring. But these sandbox containers are only supported when OpenShift is installed on bare metal, as it is for Spectrum Fusion HCI. Another OpenShift feature that is only supported for bare metal is OpenShift virtualization. OpenShift virtualization makes it possible to run Linux or Windows virtual machines on OpenShift. Another option available for Spectrum Fusion HCI clients is the ability to host an IBM Cloud Satellite location. IBM Cloud Satellite is a separate product offering that extends the capabilities of IBM Cloud into virtually any location, including the data center or at the edge. Spectrum Fusion HCI makes an ideal location for running IBM Cloud Satellite. With its bare metal OpenShift installation that supports running Linux virtual machines using the OpenShift virtualization feature, IBM Spectrum Fusion HCI serves as a factory-ready, turnkey IBM Cloud Satellite location. Spectrum Fusion HCI comes with an integrated UI that can deploy IBM Cloud Satellite hosts in a matter of minutes. As business needs grow, IBM Spectrum Fusion HCI makes it easy to expand capacity from both a compute and storage perspective to accommodate more IBM Cloud Satellite work. Let's now take a closer look at what's inside the IBM Spectrum Fusion HCI system. The base rack of a Spectrum Fusion HCI system includes what you see here on the right in blue. It is a 42U high rack that includes 2 Ethernet high-speed switches, 2 Ethernet management switches, and 6 storage compute servers that each have 2 NVMe drives. The reason for having pairs of switches is for redundancy, and the reason for having 6 of the storage compute servers is to build a complete Spectrum-scale ECE storage cluster. The elements in blue over on the right are just the base. There are options available to expand the system, You can add additional storage compute servers to a maximum of 20, which are sold in pairs. You can also add a pair of 2U high GPU servers, each of which contains 3 NVIDIA A100 40 gigabyte GPUs. Increase storage by adding pairs of drives to the storage compute servers. They start with 2, but can be expanded to have up to 10 drives per server. The drives that are used in Spectrum Fusion HCI are 7.68 terabyte NVMe drives connected through PCIe Gen 4. Within a fully loaded system, the usable capacity of a Spectrum Fusion HCI rack is approximately 1 petabyte. You can add just compute power if you wish, instead of adding more storage by adding compute-only servers. These are exactly the same as the compute storage servers, but without the drives. And for the Spectrum Scale Erasure Code Edition Active File Manager feature, it is possible to buy a pair of dedicated servers to implement that. So let's take a look at each of the server types. Storage/compute node is a 2-socket server with 2 AMD EPYC 7302 processors. These are 16-core processors, 32 threads each. And because there are 2 of them, it means that the servers have a total of 32 physical cores and 64 threads. There, in the base compute node, there is 25 gigabit network adapter card. The reason for having the 2 adapter cards is to separate the storage traffic from the application traffic. The storage traffic travels on the 100 gigabit network and the application traffic on the 25 gigabit network. There's also an OCP adapter for connecting up to the management network as well. And the drives that are used are Samsung NVMe drives, 7.68 terabytes in size. Like the compute storage server, the GPU node is a 2-socket server with 2 AMD processors in it. For the GPU node, these processors have 24 physical cores, 48 threads, which in total gives 48 physical cores and 96 threads. The RAM in the GPU node is 512 gigabytes, and like the storage compute servers, it has a pair of small M.2 drives where the operating system is installed. It has the same network adapter cards as the storage and compute server and similar OCP adapter for connecting to the management network. In addition, it has a pair of 3.2 terabyte drives for local storage. But the important thing here about the GPU node are these NVIDIA A100 GPUs. Each of the servers has 3 of these adapter cards in it. So with the pair, there are 6, and this is a very substantial amount of compute capacity. It really makes your AI and your machine learning applications fly. The AFM node is introduced to support the Active File Manager feature of Spectrum Scale Erasure Code Edition. These nodes are added in pairs, and they each are 2-socket systems with 32 cores total, 2 16-core processors. These are also multi-threaded and support 64 threads in total. The amount of RAM in the AFM nodes is a little bit less because they don't require as much. They have 192 gigabytes of RAM. The network connections are different on them as well. It has 2 of the ConnectX-4 25 gigabit network adapters. The high-speed Ethernet switches are what hold the system together. They are a pair of NVIDIA Mellanox SN3700C switches configured as a redundant pair running in active-active mode. Should one of the switches fail or need to be taken down to do a firmware upgrade or similar type of thing, the other carries the connection. The connections are dropped between them. There might be a reduction in bandwidth for a short period of time, but basically one switch covers the other so that if one fails, the other one is there to pick up the slack. Each of these switches has 32 100 gigabit ports on it, and each of the servers has a 100 gigabit connection to each of the switches, for 2 in total from each server. The 100 gigabit ports on the switches can be broken into 4 25 gigabit ports using splitter cables. This is what's done to provide the application network. So each of the servers in Spectrum Fusion HCI will also have a 25 gigabit connection to each switch, in addition to the 100 gigabit connection. These switches can carry the load. They have a total switch throughput that exceeds 6 terabits per second. They run a network operating system called Cumulus at the 4.3 level. The management Ethernet switches are how Spectrum Fusion HCI keeps track of everything that's going on and the status of the components within the rack. These are NVIDIA Mellanox AS4610 switches. They're configured as a pair, similar to the way that the high-speed switches are done. But these switches don't need to carry nearly as much data, so they only have 1 gigabit ports. They have 48 1 gigabit ports and 4 10 gigabit ports for connecting to the other switches. All of the components within the system have their management ports connected to one of the management switches and their alternate management port connected to the other switch for complete redundancy. Like the high-speed switches, they also run the Cumulus network operating system at the 4.3 level. Now, for completeness, we can take a look at the rack enclosure where all these components are put. It's a 42U IBM Constellation rack, 600 millimeters wide, 1,200 millimeters deep, and 2,020 millimeters high. It has 6 power distribution units. Each of them has 12 C13 outlets for plugging in the components. The PDUs are basically put 4 in the rack pockets and 2 horizontally mounted up near the top of the rack. So there's lots of places for all the components to be plugged in. Every component is plugged into 2 PDUs for redundancy because all the switches and servers in Spectrum Fusion HCI come with 2 power supplies, and each of those power supplies is connected to a different power distribution unit, again, for redundancy and to remove as many single points of failure as possible. There are different options for powering the rack. Both single-phase and 3-phase power is supported, AC power, and the 3-phase power can be either the Y or Delta type, depending on what geography the rack will be installed. Now, even though there are 6 power distribution units that come with the rack, if you start with just the base rack, you only need to energize 2 of those. You can basically, as you add more components to it, then you can plug in more of the PDUs. But to make those upgrades really simple, all the rails, power cords, and network cables are provided for the max configuration. So everything is there. If you need to add more servers, it's just a matter of sliding them in on the rails and then attaching the cords that are already there. In conclusion, IBM Spectrum Fusion HCI is the ideal platform for unlocking the full potential of Red Hat OpenShift. It provides application portability for enterprises that require data mobility between hybrid multi-cloud environments to allow maximum flexibility and app portability. Security, resiliency, and backup come from enterprise-grade high availability and disaster recovery, supporting hybrid cloud stateful workloads, combined with consistent security management from edge to core to cloud. Fusion HCI integrates with existing storage to efficiently use existing infrastructure and avoid the need to rip and replace existing infrastructure investments. The platform is enterprise hardened for moving mission-critical workloads into production. It provides infrastructure with elasticity and agility because containers on their own don't address running apps in multiple environments or using multiple types of storage. Spectrum Fusion HCI ensures that expensive and scarce data scientist resources have quick access to data while ensuring AI models and data are secured and protected. And with that, we've reached the end of the video. Thank you very much for your time and attention. If you'd like to learn more about Spectrum Fusion HCI and specifically the hardware behind it, please check out my blog. You can learn more about that and keep up to date on news and developments. related to Spectrum Fusion HCI. Thank you.